All right, good morning, everyone. My name is Craig Sipes, and I am the STEAM coordinator for Local District East. And this morning, we have got an awesome treat for you. For our virtual field trip today, we are with the USC Sea Grant. And with us today, sharing with us, we have Linda Chilton and Charnel Wycliffe. And they are going to share with us some of the wonderful research and findings that they have going on with the USC Sea Grant. Today's question, our guiding question for the field trip today is, how do scientists know things about the ocean? So did you have a chance to talk about this with your teacher? What do you think? How do scientists know things about the ocean? What do they do to find things out about the ocean? And how does this connect to the question that you're dealing with in your class, which is, how will spruce survive when she's released into the ocean? So how do those two questions connect? What do you think? So today, we're going to learn more about how do scientists know things about the ocean, and we're going to learn more about Spruce the sea turtle, and will she be able to survive in the ocean thanks to the help of the USC Sea Grant. Thank you. Welcome, Linda.
Thank you, and good morning, everyone. It's so nice to be able to have a chance to visit with all of you today and to learn alongside and find out more about what a researcher is doing to find out and study the ocean. Charnel is a researcher. She's also a student and a graduate student up at Moss Landing up in central Northern California. And she's going to share with us some of the technology that scientists use in studying the ocean. And I'll turn things over to Charnel, but nice to be with you today.
Good morning, everyone. My name is Charnel, and like I was just introduced, I am a grad student at Moss Landing Marine Labs. I just finished my second year there, and I am looking forward to sharing with you some of the things I've learned about the ocean and how scientists study the ocean. So I'm going to share my screen. So one thing I wanted to tell you guys about, I have this little icon here. This will just be a way to let you guys know that when we see this icon on the slide, that will be the time where I'll start asking you questions, and then you guys could break up into your groups and talk amongst your classmates and peers and with your teachers, just to try to discuss what's going on in the slide and any ideas that you generate. So one of the things that a lot of scientists are really good at, they're really good at observing things. They observe animal interactions with other animals. They observe how animals interact with their environment, the changing tide. I actually grew up not too far away from where you guys are now. I grew up in Long Beach, California, and my parents used to take me to the Cabrillo Aquarium down in San Pedro, and also to the Bolsa Chica wetlands in Huntington. And I remember observing one time at the wetlands, maybe 30 pelicans or so in the air, just flying over the water. And then I just watched them dive into the water. I had no idea what they were doing. And so I asked my dad, like, what is going on? And he was telling me that's how they feed. So what they do when they fly over, they see a fish and they just dive bomb into the water with their mouth open and then scoop the fish up in their mouth, which is really cool to see. So that's just one way that scientists just start going through, they start looking and they just take note of what's going on in the environment around them. Some cool facts about the ocean that you may already know: 75% of the earth is covered in water. There are hundreds of thousands of marine life already discovered, and so many more that have yet to be discovered. The deepest part of the ocean is called the Marianas Trench. It is about 36,000 feet 1,100 meters, 1,000 meters, sorry. And just to give you a reference of how deep this trench is, if you take a school bus, say about, the average school bus is maybe about 45 feet long. So if you take one and you stack them, stack one and then another one and another one and another one, you would need about 800 school buses just to reach the bottom of the Marianas Trench. It's so cool. So that's just a few fun facts about the oceans that I just wanted to share with you. Um, and then going on to our next slide, what scientists start to do, they start to ask questions about the things that they observe. So the things I just share with you, facts about the ocean, um, those were generated through questions. Like people had to ask questions and how to find those answers. So what I'm going to do is just take some time to just let you guys generate some questions. What questions do you have about the ocean? What questions do you have um, about just some of the things that you've seen in the ocean? Or I understand you've went to the aquarium, Long Beach Aquarium, or even things about just some things that you've come across in your science classes. So if you guys want to take some time to talk about the ocean and just generate some questions, here's a chance. Yeah. Okay, so it looks like we have a question that just came in. Um, are sea stars or starfish and sea stars different? Was there a difference? There's actually not a difference between sea a starfish and a sea star. It's actually just they just changed the name. The old name for a sea star used to be starfish, and I'm not completely sure the reason why they changed it. I think just to separate a fish from a invertebrate, because the sea stars are considered um, uh, not to be a fish, so they wanted to just change the name so it just gives them that separation. Um, ooh, what do sea stars eat? Uh, they actually will eat mussels and different urchins, and we could find sea stars in the uh, different rocky intertidals, or even sometimes down on the bottom of the sea floor. It just depends on where, what type of sea star it is and what they are going after to eat. And then we have one, what equipment is used by marine scientists? Marine scientists use a lot of different equipment. I will actually be talking about a particular equipment that I use later on in the slides, but marine scientists can use anything from satellites to to tagging animals to track them, as well as just scuba diving and going out on boats. Ooh, how does the moon affect the sea? So, the moon and the Earth rotation and the sun actually play a really good part, or really crucial part in the tides that we see. So, the rising and falling tides, and how strong those tides uh, are strongly influenced by the gravitational pull of the moon and the Earth's alignment with the moon and the sun and sort of things. Hopefully that makes sense. Um, okay, so I'm not sure why sea stars have different structures, but in a sense, most sea stars are actually kind of spiky. They are in a family called echinoderms, and that just means spiky skin. And so some of them will feel a little bit smooth, but some of them can also feel rather bumpy when you touch them. And so in some sense, they do have all have spiky skin, but why they have all their different structures, I am not sure on. Any more questions? Okay, so I'm going to go ahead and continue on, and then any other questions that come in, I'll try to answer them and respond to them um, later on. So, but these are all great questions. Very good. So what do we do after we have all these questions? Where do we go? What do we do with them? So initially, what happens is that once we have our basic questions and try to figure out some of the information, we go find background information. So we'll go to different libraries, we go talk to different people, different aquariums, and we will read books, we will read different scientific papers, uh, read different news articles depending on if it's relevant to your topic or interest. So if you wanted to learn more about sea stars, there are various different articles that will come out about sea stars and their diets and things. And then we also talk to an expert. There's um, whatever you're interested in, there's bound to be an expert in that field. So there are definitely people out there who know more about sea stars than I do. There are people who know a lot about sea turtles like spruce, and then there's um, different people at the aquariums that you can talk to as well, just to get some background information to help you really focus in on your questions and how to really jumpstart that next step, what we're going to go into, which is your experiment. Or and for me, my experiment is just encapsulated in like my thesis. Um, so before I go into like what um, the main jumping point for research questions, I'm just going to talk to you a little bit about what I do. Um, my thesis, which is basically um, my really big research project, uh, is out at Catalina. I am studying an algae that is a Caroline algae. It is a red calcifying algae. And so calcifying basically means that this algae is able to pull calcium out of the water to help build its exoskeleton, its structure. So it is a hard algae. And just like you would drink milk or eat cheese, or if you like broccoli, to get calcium into your body to help build strong bones and teeth. This algae will pull calcium out of the water to help build strong structure for themselves. This algae bed, maybe a very important very important nursery ground, sorry, for the small invertebrates and fish. So tiny, like maybe half an inch urchins have been found living in these beds. And what happens is the nursery ground is a place where these small invertebrates and fish can hide out from the bigger fish and bigger animals that will try to eat them, but also provides them with a way of gathering food for smaller invertebrates or smaller food particles that will come through and come through the little crevices of the rotolith bed. So this is just a picture of a bed. These are the individual rotolith beds, or rotoliths, sorry, and all these little individuals form a bigger bed. So they're not attached to the ground at all. They just congregate together and form these amazing purpley pink color beds. Um, so one of the ways that one of my advisors used to survey these beds is she used scuba diving. So scuba diving is a great way to look at the ocean. You put on a tank and you have a mask and you get all gear up and you go down and you basically have this apparatus that helps you breathe underwater. So you can see all these colorful and beautiful habitats where there's fish and sea stars. And sometimes you see like stingrays and other diving birds while you're underwater, which is really cool to see. And so, with my thesis and where I'm coming into with it is because scuba diving is somewhat limited on how far they can go. They can't really survey a full bed extensively as they would like to, so they can't always get in the uh, explore as much space as they want to because they are limited by how much air they have in their scuba tank. Whereas what I'm looking at and trying to do is see if there is a faster way of surveying the beds where we don't have to use someone on scuba. And so that's where the drone comes in. So drones have been used or are starting to be more popular now in the marine science world, where they are being used to look at sharks and whales and even some sea turtles. And they're a great tool because you can program it to go where you want it to. They have to be still in line of sight. You still have to be able to see the drone. So if I'm on Catalina, I can't send it back to the mainland to do a survey because I can't see the drone from there. But I can send it out just about maybe about 100 feet or so more to survey an algae bed while I'm standing on the um, beach. So so one reason why we're using the drone and looking at the drone because it would be faster, or potentially faster, to use the drone to survey the beds versus having someone in a scuba gear load all their gear up, go down underwater, and take maybe about an hour or so just to do some of the normal stuff that they do in just a small area. So and in just a small area. So to have them go and look at the full bed would actually take them a lot longer. And they would actually have to come up, get a new air tank, and then go back down to continue surveying the bed. So my question is there a faster way to survey rotolith beds other than scuba? And then with the drones, can the drones actually detect the beds? So, for my super question or my hypothesis, which is the starting point for all science research, um, is if a drone can be used to map roller beds in Catalina with 8 centimeters, which is about 3 inch revolution. I'm not sure um, how much you guys know about camera resolutions and pixels. Um, okay. So basically, resolution is basically how much or how clear of it of I guess of a pixel or an image something will be. And so up to about 3 inches from the drone, um, that's how clear that picture or that piece will be. Anything smaller than that, it won't be able to pick up or see. Um, and and so that's just part of resolution. But to just get to the part where I test my hypothesis is that when I went out to fly the drone the first time, I had to pick about 2 different heights to figure out what will give me the best image. So 60 meters is about 4 school buses high in the air. Again, if we're looking at that 45-foot school bus, that's about 4 school buses back to back, to 80 meters, which is about 6 school buses back to back. So I could still see the drone, that distance away, uh, which I need to be able to see the drone. And then from there, I had to, once I get the images, I have to go through and put them in a software so that they can actually look nice. So what ends up happening when I fly the drone out is that it takes pictures um, with a certain amount of overlap to of the area that I want it to take. So as it's flying, it took maybe about 6 to 8 minutes. And as it's flying, it's able to take these photos, and then it will use a software to put them all together. So if you can imagine, if we had to take 100 pictures with a regular camera and then try to put them all together and match them perfectly, it would take a lot longer for us, and then probably would not be as fun for us to do that. But we have this great technology from the drones that will actually stitch those images together. So testing your super question. One thing that I talked about a little bit is just the whole was just the uh, part about uh, flying a drone and things like that. But one thing that we have to consider, so one thing when we are testing our questions, we have to come up with a plan and create a method for it. So in creating a method for flying a drone, what do you think are some things that I would have to consider in flying a drone? So I'm gonna let you guys take some time to think about that and ask your peers. Okay. Okay, so we have a question. Can drones can the drone go underwater? So this particular drone and the image cannot, but there are what are called ROVs, which are remotely operated vehicles, and those can go underwater. And those you have like what looks like a gaming cube, a gaming console or game controller, sorry, that you can control that underwater drone, but you cannot use a drone like this underwater. I'm going to go ahead and with some of the things that we consider for flying the drones, and that you can still add into that if you want to. But one thing I have to consider is like how high to fly the drone, how fast to fly the drone, because if I fly it too fast, I'm just going to get a smudge instead of actual clear image. What time to fly the drone. So early mornings are usually best because it's the winds are usually calmer and the sun's low enough so it doesn't reflect so much on the ocean surface, so you could get a glare from the water. And I usually fly at low tides if I can, just so that way there's a little bit less water between the surface and the actual algae bed, but also because I fly from this beach. So if the tide's coming in, I am limited on how much beach space I have to take to fly and land the drone safely without getting into water. And I also, like, if it's rainy weather, I can't fly it. Or if it's like super windy, I also cannot fly it then. So this is actually one of the rotolith beds that the drone was able to capture. This took about 123 images that you see here. I flew the drone fairly high, the winds were low and the tides was going out, and the orange arrows are actually showing where the beds are. So it's really cool to be able to see the beds and not have to go under the water to see them. So this, like I said, is at Isthmus, and this one right here is Emerald Bay. This is about 100 pictures here, 80 meters high, so that's that 6 bus distance between me and the drone, low tides, calm winds. So this just answers the question of, can the drone actually do this process? For me now, it's asking another question of, okay, so can the drone actually measure these patches here? And is there any seasonal variations between the bed's perimeter, which is this area right here? And so I will go on to the next one, and then I'll answer a few questions here. So this is, I know this looks like a lot, but this is basically what I just walked you guys through, from observing to asking the questions to going and doing our background research in the library or reading books or asking an expert, to building our super questions, something that we can actually test, and asking the critical questions of like what we actually need to test our hypothesis. And then, does our work actually, is it working? Did it actually go and test, or not test, but give us the results for our hypothesis that we're looking for? If not, then maybe we need to troubleshoot our test experiment. If it does, we can analyze the data, or sometimes we go back and ask more questions. A lot of it is asking a ton of questions. And that, I will take any more questions that you have. Let's see. As you see that we have a few questions. One of the questions asks, are drones waterproof? Again, it depends on the drone. Most aerial drones are not waterproof. You would need like an ROV or remotely operated vehicle to go underwater. Bad weather it can really affect your drone. Some drones can actually handle some rain, but this Phantom 4 that you see in the photo here is not very good in bad weather. And drones can sometimes get stuck out of range, which is why we try not to fly it farther than the range of the remote. Yeah.
Well, Charnel, thank you so much for taking your time to share with us some of your learning, a lot of your learning here, your project, your thesis, and everything that's going on with the scientific endeavor that you're under as a marine scientist. Can you just briefly tell us what was your path into going into doing marine science? What were your interests? What brought you to the place that you're at now?
That's a very good question. Well, like I said, I grew up in Long Beach, and so trips to the San Pedro Aquarium as well as the Bolsa Chica wetlands definitely influenced uh, my wanting to go into marine science at an early age. And then after that, my parents actually moved to the high desert. So there wasn't any water, lots of sand, but no water. And I think there's where I really started to just kind of find things on my own to discover. I worked at a child and youth program, so I was able to actually take some of my love for science and marine science into that environment. Talk to them about bioluminescence, which are created by these little individual like creatures in the water, which when excited gives off these wonderful lights. So if you know anything about bioluminescence, it's fantastic and it's beautiful. And that's actually what really got me into marine science, really pushed me into transferring to Monterey Bay, Cal State Monterey Bay, where I did my undergrad and got my bachelor's, and then keeps pushing me on, I guess, to discover more about the ocean. Yeah.
And bioluminescence is pretty magical. Those glow-in-the-dark little microorganisms at nighttime, if you move your hand through the water, then it just leaves this rippling glow-in-the-dark trail from where your hand was. It's completely magical, but it's science, which is even better. So, so thank you so much today for coming out and sharing with us. And Linda, thank you as well. We appreciate you. We appreciate your work, and we appreciate your contribution to our summer school STEM ventures, where today we have been investigating the question of how do we know things about the ocean. So that was our question for today. So as we're going back to our classrooms, then we'll be thinking about what we've learned today, and we'll be considering what was it that we learned about how do scientists, how do people, how do we know things about the ocean? So what is it that you learned today that helps you to understand how we actually do know things about the ocean? Thank you very much, and we will see you all for your next virtual field trip on Thursday. Have a great day.
Bye, everyone.
Bye.